All right, well, we'll start with our regular warm-up, so I'll give you guys some time. But remember, you're gonna look for as many fractions as you can. So I'll give you a couple minutes to think and write, and then we'll share. And adults are juggling a lot of things. I have a lot of students who are also working. I have a lot of students who are working and parenting and just who have many, many responsibilities. I think part of how I try to manage it is partially in how I structure my curriculum, like the way I teach math. When we're doing a certain unit, it does build, but we also do a lot of cycling. So there's a lot of revisiting the same concepts, but from like different perspectives, a lot of revisiting the same big ideas, but like in different contexts, which I think is important both to help manage this, the fact that everybody's gonna miss some classes. And so that way they're all still getting exposed to the big ideas, but it's also very helpful in terms of how people learn, because anytime they see something, that's not the only time they're gonna see it. It's gonna come back. And then they're going to see it again, and then they're going to see it again, which I think is really helpful when we're trying to teach people to understand these concepts in a really deep way where they can actually apply it later and hopefully learn it in a way that's going to like stick with them, and really be permanent. Anyone have some fractions we can start with? The purple?
Yeah.
Okay. So how do you want to describe the purple?
4 parts.
Okay. 4 parts.
Out of 4.
Out of 4. Okay. Out of 4 parts?
Yeah, out of 4, whole.
Okay. So what are you seeing as the whole? Or do you want to show me what you're counting for the 4? I want to make sure I'm understanding.
Yeah, I
it.
counted the 4 inside the whole cake,
Okay.
Yeah.
So when you counted these 4, were you counting
Yeah.
the triangle shapes?
Yeah, the triangle. Yeah.
Okay, so you were counting 1, 2, 3,
And 4.
4 triangles.
Yeah.
Okay. When you're counting the whole, were you counting the same 4 triangles or something else?
No, the same for triangle.
Okay, the same 4 triangles.
Yeah.
So if we were only looking at this side, right? This side has 4 pieces that are all purple.
Yeah.
What if we wanted to include the entire thing? How many pieces of that size would you have in the whole thing?
8
Okay. With the same triangle shape?
with the same triangle.
All right, so 1, 2, 3, 4, 5, 6, 7, 8. If that's our whole, what would the fraction become?
4.
Mm-hmm. And what would you put as your whole? Or your total number of parts?
8.
8, right. So that's a good example of what we've been talking about in terms of a relationship between a whole, and remember they had to be all the same size. So in this case, they're all those same size triangles. And then 4 of them are purple.
Yeah.
Awesome, thanks. Okay, another fraction.
I picked the gold one.
Okay.
Yeah, represent 1 under A.
So your whole was also 8? Did you see the pieces the same way? Were you looking at the triangle pieces? Okay. So both of these are using these 8 equal parts.
Yeah.
Great. What other fractions do you see? What do you see, Alan?
The red one.
The red one?
Yeah.
How would you describe that?
2 parts
Okay.
out of 8.
Out of 8. And again, same pieces
Yes.
you see in the triangles?
The same.
Okay.
Yeah.
Good. All right. So now we have all of these as fractions where we're using these pieces. Now, what if we chose different size pieces? Is there another way that we can break this whole or this cake into equal size parts?
Can I show it?
Yeah, sure. Please come up. Here, let me make this a better color. There you go.
Going to cut it here.
Okay.
So we have now 1, 2, 3, 4, 5, 6, 7, 8. So for the pupil, we have now 8 pots.
Okay.
For the red one,
How many do you have altogether? Like, how many of those smaller triangles have you made out of the whole thing?
okay, 8, 9, 10, 11, 12, 13, 14, 15, 16 parts
Okay.
total.
All right, so you have 16 parts.
Yeah.
Now, all of those parts that you just created, are they all the same size?
It's in the, this one is more smaller than the others.
Oh, you have one that's smaller.
Yeah.
Okay.
So if we want to equal, we can
Yeah.
use
Use your
that.
flat hand and you'll get the eraser. There you go.
We can make it like this. And we have it equal.
Okay.
11,
Yeah, now it looks like the other ones.
13, 14, 15, and 16.
Great. So you were talking about the purple. Can you write the whole the fraction that you would do
Okay.
for the purple?
For the purple one, we have 18 out of 16.
Great. All right.
Yeah.
Good.
For the gold one, we have 2 out of 16. For the blue, we have 2 out of 16. And for the red, we have here 1, 2, 3, 4. We have 4 out of 16.
Nice. Thank you. Does anyone
No.
have any questions for Alan? So now we have another way to write these fractions, but the pieces got smaller, right? But they're still all the same. It's still the same whole. We still have the same amount of each color. So that means that this fraction is equivalent or equal to that one because they're both talking about the purple. It's just a different way of cutting it. Great. When it comes to language skills, in the math class, you know, there are sometimes there's a specific focus on language. Like when we're talking about ratios, we actually just did a whole unit where we were looking at both the symbols used to represent ratios, but also the language used and how just the shift of a couple prepositions can make the difference between a ratio that's comparing two separate groups, like saying, you know, the ratio of students to teachers, and how just shifting a little bit, like to say the ratio of 4 students out of 5 people, just saying out of all of a sudden makes it part of a whole, and those small changes in language can actually change their understanding of what's happening. So generally, when I'm teaching, there is a lot of like peer-to-peer interaction and there's a lot of discussion. So we do have a lot of folks who are either currently English language learners or who formerly were learning English, and so it gives them a lot of just like natural practice to use that because they're communicating with each other and they're communicating with me. But I also, because they have the opportunity to explain their thinking, I feel like that's a skill that I'm trying to give them practice with. There were a couple ways we wrote fractions for the purple. We had 4 out of 8. We had, I think it was 8 out of 16. And then we had 16
32.
out of 32, okay? But they all represented the same portion. What happened to the numbers as we cut the pieces smaller?
Multiply by 2.
Oh, that's interesting. Can you say more about that? Yeah.
Yeah,
Where do you see the multiplying by 2?
because 8 times 2, 16, and 16 times 2, 32. 4 times 2 is 8, 8 times 2, 16.
Oh, nice. Nice. So every time the numbers doubled, but the amount didn't actually double, right? Which means those fractions are actually equal. And this is a pattern we've been seeing over and over, both with our fractions and our ratios. Anyone remember what this is called when we're multiplying by the same on the top and the bottom? I'll help you out.
Portion.
It's a property
Property.
of equal
Proportion.
ratios or equal fractions. Because fractions are ratios. They're a certain type of ratios, okay? Part-whole ratios normally. So, very nice. Now, which one of these had the smallest size pieces? When we did 8, 16, or 32? So the one that's still up here, this was the 32,
That,
right? And this is how big these pieces are. When we did 8, we were using the triangles that were here already, like this, right? This was our total of 8 pieces, right? So what happens as we cut more pieces? What happens to the size of the piece?
Smaller.
we're gonna get more smaller.
It gets smaller,
Yeah.
right? The first time Alan cut it, he cut them in half, so we got twice as many pieces, but they're half the size. And then when Abdu cut it even more, they got half the size again, but we got twice as many. So we keep getting more,
Yeah.
but they're smaller. Nice. All right, I'm going to show you just one more thing quickly with this. We can also put these smaller pieces together to make even larger pieces. So for example, I could cut this whole cake into just 2 parts.
2 parts.
Right? Now this one's got a couple different colors in it, but this one is all purple. So how would you describe the fraction for purple in this one?
1, 2,
Yeah,
1, 2, yeah.
1
2.
out of 2, right? There's only 2 parts now, and one of them is purple, right? And that's a very common fraction, that's our half. So in fact, all of these different fractions for purple, they're all equal to half. All right, nice. Okay, so what I want to do next, we're going to be building on what we did on Tuesday. And I know not everyone was here Tuesday. A couple people were. I think you guys were here Tuesday. So if you were here, I might ask you to help me out a little bit. We're going to refresh what we started talking about. And I want to start by looking at this idea of how we can change the way a picture looks. Okay. Have any of you used Microsoft Word or PowerPoint or slides or anything to like work with pictures and change their size? Well, if you ever do, one of the things you'll notice is that if you have a picture, and here's our beautiful vice president, right? There are these different points that you can choose to stretch the picture, okay? So there are some ways that I can stretch this picture and make it larger, right? And Kamala Harris still looks the same, right? Her face looks fine. We haven't made anything look weird. There are other ways that I can enlarge this picture that don't work as well, right? So I've made it larger, but now the face doesn't look the same, right? It looks stretched out. And there are different ways that that can happen. Right? There are ways where it could have become stretched the other way. When this happens and it no longer looks the same as the original, we call that, the picture is distorted. Distorted. And we can usually tell that with our eyes, especially with something like a face, because we know what faces look like, and so it's very easy to recognize when a face has been distorted. Okay? When you have an enlargement, or even you can make it smaller, if it keeps everything looking the same, we say that the 2 pictures are in proportion. Right? And we have used this word proportion a lot in this unit because it has to do with ratios. All right, so that's what we've been exploring, and we're going to keep exploring in this idea, is that there's ratios and mathematics involved in how we keep a picture looking right as we make it larger or smaller. So what we started the other day, we were looking at this lady here. This is the Mona Lisa. It's a famous painting. And this is page, hold on, let me get the page for you. This is in the green packet, page 32. So you have a reproduction on page 32 that is a good reproduction. So the one on your page is in proportion to the original. And what they told us about the original is that the real painting is 30 inches tall, right? Our reproduction is obviously much smaller. So what we were doing on Tuesday was trying to figure out how wide is the real painting so that it will, it will have the same face without being distorted as the picture here, okay? Anyone who was here Tuesday want to talk at all about what we did with these and how we figured out those dimensions?
We took the measurement.
Mm-hmm.
We measure the longer and the width and the length. So the length is I think it was 3.
Mm-hmm. Yep, so I'm going to call the tall one the length.
Mhm.
Yep.
And the bottom is 2.
Good. And this is the one on your page. Like if you take those rulers on your table and you measure the one on your page, that's what we got. Okay. Great, so that was the little one. All right. How do we use that to figure out the size of the original, the real painting? So 3 tall and 2 wide, that's this one.
Yeah, you will measure both sides.
Okay. How do we figure out? So they told us that the real one was going to be 30 inches for length. The real Mona Lisa, 30 inches tall. And we had to figure out, well, how wide would it be? Right? How do we do that based on what we know from this little one? Because that's what we created here. This is the actual size.
So now what we're gonna do, we're gonna look the portion and the size.
Are you thinking about proportion in terms of when we set it up like that?
Yes.
Okay. So how would you set up the ratio? Do you remember how we did that?
30 by 3, something, no? If I remember.
So yeah, I mean the 30 and the 3 are part of it because this is our original length. Okay. So we'll do, this is 3 inches
And the other is 2 inches.
and the other is 2 inches. So here's the width. So we have basically length
Length and
width in this relationship, okay? So remember, one of the things we were doing was we were looking at the fact that, okay, this already up here is enlarged, right? Because it's being projected. It's gotten bigger. But we could think about it as the original
Okay.
is 3
Yeah.
inches. It's
Yes.
3 parts.
the bottom and 2.
And the original here
Two.
is 2 parts,
Yes.
okay? Right, so this isn't perfect, but right, that's kind of roughly inch-wise. That's what we have on this little one. Now the original is bigger. We were told that the original one is actually 30 inches tall, and meaning the real painting that's hanging in a museum. Okay. So on the real painting, this is actually 30. And what we were trying to figure out was, well, how wide does it have to be then to still match that 3 to 2 relationship? many times could I fit this little one inside
10.
of the real one? Remember we did that the other day? Yeah.
Mm-hmm.
So we took this and we said, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10. Mm-hmm.
The little one to the original size, it's 10 times larger or 10 times taller. Okay?
The measurements times 3 in this case.
So in this one, what I was trying to do here was I was showing in the small one, this is 1 inch, 1 inch, 1 inch. It's 3 inches to 2 inches. Okay. But if this is actually 30 inches, how much would each of these pieces be?
6.
Okay. Let's see. So if this was 6, 6, and 6, 6, 6, and 6, would that be 30 inches total?
No.
10, 10, 10.
Okay, so let's try 10. Sorry, it's getting messy over here. All right, so we want it to be 30, but it's still got 3 parts. So it could be 10, 10, and 10. So now a part is 10 inches instead of being 1 inch. Okay? So how big would these parts be?
25.
10, 10, 20.
Right, they're still 10. They're still the same parts. So we've got 3 parts of 10 and 2 parts of 10.
Yeah.
Before we had 3 parts of 1 and 2 parts of 1. So the original turns out to be 20 inches wide and 30 inches tall.
Yeah.
Okay? It's bigger, but it still has the same relationship between the height and the width so that the picture won't be stretched. It won't be distorted. Okay. There's a lot of patterns in here, right? This was one pattern, seeing the 3 chunks of 10 and the 2 chunks of 10. The other pattern was we saw that just as this one, we could do it, it's 10 times as tall. It's also 10 times as wide. So we have the 2 inches, 10 times gives us the 20, okay? So what is the mathematical relationship here? What do you
Times
say,
2.
Maria? Times 2?
Times 10.
Times 10, okay, good. Right, and there's a couple different ways that shows up. It's 10 times as tall, 10 times as wide. And also, another way to think about it is it's 3 groups of 10 and 2 groups of 10. Both of those are ways of thinking about how that relationship changes. But now again, we see that property of equal ratios. Property of equal ratios, just like when we were doing 3 mangoes for $2, right? It's a completely different context, but they're still ratios. And so that means this ratio relationship is equal to this ratio relationship. They're in proportion. Okay? So that's where we started. Now what we're going to do now is we're going to take it one step further. Oh, come on in, Sue-Ann. Welcome, welcome. What I'm going to give you is a whole bunch of Mona Lisas. So in your pair, there should be 7. Some of them are big and some are small. What you're going to do with your partner is you're going to look at each one and you're going to decide if you think it looks in proportion or if you think it looks distorted. So that's all you're doing to start. And you can look at the original that's on either up here or on your paper to see, like if it looks like the face is the same. You just want to sort them into 2 piles, in proportion and distorted. Okay? So there's been a lot of work leading up to this particular lesson. I do a lot of work in my class around just establishing the atmosphere of the class and the expectations of the class in terms of students know that I'm usually going to ask them to work together. They know that I'm not just going to put notes on the board. They know to expect me to ask them to solve different kinds of problems. Some of the students in the class today have been with me for a while, so they kind of know what to expect. Some of them are newer, and so they're still kind of getting used to that. let's see what people think, because if you flip them over, there's letters on the back. You all have the same ones. All right? So can you give me one that you feel really confident is a good reproduction, is in proportion?
Yeah.
That's
What's a letter that you think is a good one?
Those together.
F? Okay. What do other groups feel about F? Let me find F. F is a big one. Looks like this.
Yeah.
Yep. Oh, sorry.
So I changed that one to an E.
So, wait, F was a good one?
Yes.
F is a good one? Okay.
F is a good one.
So F is a good one. All right. What's another one that is a good one, is in proportion? Which letter? D.
D. I have
D. Okay.
D.
We like D too.
I told you.
Okay. What else looks good in proportion? C. C is a medium-sized one. People like C?
I get it wrong.
A.
Yeah.
A is a little one. People like A is good? Okay.
This A.
Were there any others that you felt were in proportion? Or the other ones were distorted? Let's look at the ones you thought were distorted. So B is a little one.
Yeah.
People thought B was distorted, bad reproduction.
You see?
Which letter? G. G is a tall, skinny one.
Yes.
Okay. Bad reproduction. Okay. E. People thought E was bad. All right. Well, it looks like based on our visual sense, everybody agreed on which ones looked right and which ones don't look right. Okay. How can we use numbers to see if we're right?
Four by three. If 4 people say
What's that?
4.
How could we use numbers to check whether the ones that we said were good and in proportion? How do we know if they actually are? They look good to our eyes, right? But how could measurements and numbers help us to test?
4 by
4,
So
it's almost like 4 person agree that good reproduction and 3 person for bad. So that's like 4 to 3.
Okay, so you're describing how many
Yeah.
are good and how many are bad with a ratio?
Yeah, with the
Okay,
ratio.
that would be a 4 to 3
Yeah, 4 to 3.
ratio. But what I want to look at is
The
measurements of the
measurements.
actual picture.
Oh,
Right? Like remember what we did over here where we were comparing the original size painting and a good reproduction, right?
yeah. So for F, we have
9-inch.
9 inch
Okay.
in length, and we have
6.
Let's see.
6 inches in width.
All right. So F you said was 9 inches in length, the long one. Okay. And what was it? 6
6 inches in width.
in width. Oops, I meant to write inches. Okay. All right. Is there a way to see the original ratio in that? Because remember, our original ratio was 3 inches to 2 inches.
So we work with this one.
9 over.
So this was the original ratio for the small one that we started with. Does this have an equal ratio? Is what I'm trying to say. Is there a way to show that this original is equal to the one for F?
Yes.
I'm hearing a lot of people say yes. How
Yes.
can we prove that they're equal?
3
What do you
times. 3
think, Kevin?
times.
3
times 3.
and
3 times 2.
Okay, so we've got that factor, that number we're multiplying, that's the same. Now here's the one from last class. Here's F. How much taller is it? 3 times,
3 times.
right? And that means it also has to be
2 times wide.
still 3 times wider, right?
Times wider, yeah.
Because it started out as 2, so it's 2 times 3. Good. So numbers prove, yes, we were right about F. F is a good reproduction. It's in proportion. Okay? All right, take a couple minutes to do the same thing for the other ones that we said were good reproductions. See if you can prove with measurements that they are actually in proportion. So you're testing out A, D, and C.
So I think we get 707.
It's a little bit.
Yeah, 707.
So we have 1, 2, 3, 4, 5, 6, 7, and a little bit off. And then we have 5. 5. So then let's do this and see. We have 1, 2, and just a little bit. And if we come down here, it's about the same thing. We could try that and see. So this
But
one,
notice
we have
something. On
7.
this one, it's 2 times the height,
Yes.
but the width, it's actually 1.
Oh.
Okay. It is 2 times the height, but then that's a different measurement. Does that make sense? Was this a good reproduction, or was this one distorted?
It's a good one.
Does the face look the same?
Oh, no.
Yeah, this is one where it looks like something went wrong, right?
Yeah.
And one of the things is that it doesn't actually work.
Yeah, because it's supposed to be 3 times.
Right, or at least the same.
The same,
If it's
okay.
gonna be 2 times as tall,
Okay.
it should be 2 times as wide, but it's not,
Okay.
right?
Okay.
Okay. So where's the ones that you thought were good,
Oh, one of them.
the good reproductions?
We don't have any. Only
That one's
the
F,
Yes.
okay. What about, were any of the other ones the face looked okay? Or you can check them all in that way if you want to. You can see if they do that equal.
Okay.
Okay.
Oh, I can see.
But if you think it's
This one.
not a good reproduction, then we think that it's probably not in proportion.
Okay.
Okay.
No.
Which were the good ones?
This one we get 3. We got 3.
Mm-hmm. So it's 3
Yeah.
times the height?
The
Okay.
height and 2 times across.
So is this one that's in proportion? Or is it distorted?
We still have a little bit of inches. So we were just wondering if we should just round it off.
You mean it wasn't
yeah.
like exact?
Exactly. It was just.
Oh.
like
What
a
are
little
the
bit.
measurements of this one? Like
This was
if you do
3
inches?
long and 2.
Well, it was 3 Mona Lisas long.
3 Mona
Right?
Lisas
How,
long.
how many inches? Let's
We
look at
got
both.
9.
Okay, so it's
9.
9 inches.
Yeah,
And how many inches is it wide?
and 4.
4. 4 and
4.5, I would say.
4.5.
4.5. So it was 9 by 4.5. Okay. So let's look at that as a ratio. 9 and 4.5. Okay. Is this an equal ratio to this, and how would we know? That's what I want you guys to think about. Because if it is a good reproduction, if it's in proportion, the ratios have to be equal.
No, it's not.
It's not? How do you know?
Because the 4.5. That we have. I lost what I want to say.
I don't know if I'm wrong.
Go ahead, Kelly.
We can make 3, no, it's not gonna be because 3 times 3 is 9, and you gotta go 2 times 4. No, it's not gonna be good.
No.
Or you can, if only thing we can round it, make it 3, the bottom 3 too. It's not gonna be done. No.
The picture is distorted.
It's this dot.
So that one is distorted?
Yeah.
If it was in proportion, what should the width be?
3,
3.
It should be 6, which
yeah.
is actually what we had for F,
Yeah.
right? So which was the one we were just measuring? Was it
G.
G? So if you hold up G and F, they're the same height,
Yeah, but not
right?
the same.
But they're not the same width,
Yeah.
right? F was the one we showed was in proportion. This is the one that has the correct relationship, the correct ratio. This one is too narrow.
So this one.
Okay, that's why her face looks kind of stretched and skinny, because it's not in proportion. Okay.
And then we try this one. We got
We got
7,
7.5,
7 and
7.5.
So that was what letter? E? No, that was
3/4.
G. G did not work.
This we got 6.
G was
6,
9
and 6.
by 4.5. Okay.
Seven and some. And then, yeah, and 5. The next one is D for the bad reproduction.
What letter, sorry?
D.
D?
D.
And that was bad or
Yeah.
good?
Bad.
Bad. What was your measurements on D?
The measurement we got on this one was
7.5.
7 and I won't quite say 7.5. It's
Okay.
like 7 and 3/4.
I think it's okay to say 7.5
7.5?
is a
Okay.
pretty,
7.5.
pretty close. Yep.
And then
And what was the width on that one?
5.
5. Okay. Now D, I think, was one of the ones when we were looking at it, people thought it looked good. So let's test with the numbers, because it's possible that we were wrong when we were looking at it. But you're saying you think this one is not in proportion. So our original ratio was 3:2. The measurements on D is 7.5 and 5. Any thoughts on how we can test if those are equal?
We already test the E.
Which one?
The E.
No, we're looking at D right now. I mean, you guys may have been looking at a different one, but
Okay.
up here, this is D. 7.5 tall and 5 wide.
Three by 2. Yeah, that is.
Tell me what you're thinking. This one's interesting because we don't have all whole numbers. So 1 Mona Lisa,
One Mona Lisa.
2 Mona
Two
Lisas,
Lisas.
and then extra.
And
How
some
much extra? Let's kind of look at it.
Like 1 inch.
2?
2.
Well, we're measuring in Mona Lisas, so let's do 1 Mona Lisa, 2 Mona Lisas,
So that's,
half a Mona Lisa?
yeah.
I mean, does that look like half the Mona Lisa? Or?
Yeah, 1
Okay.
and a half.
So if we're measuring in terms of this, we had 1, 2 and a half
Half.
Mona Lisas.
Yeah.
If that's going to be our unit. All right, what about going across with
And
the Mona
when we
Lisa?
go across, we get 1, 2. That's a half.
Well, that's an inch, but how many Mona Lisas is it?
2. 2
So there's
Mona Lisa
2 Mona Lisas and
1
1 inch.
1 inch.
which is also Half a Mona Lisa.
Half a Mona Lisa.
So there's something interesting here. It's not a whole number,
No.
but there does seem to be a pattern. So it appears to be like 2.5 times as tall. I don't know where mine went.
But we're supposed to have 3. Let's see.
Let's see what we can do with this number 2.5. 2.5 Mona Lisas tall, 2.5 Mona Lisas wide.
Wide. Oh, yeah.
So let's see what that does with numbers. 2.5.
So then the other half, the both halves makes it one whole. And then we have 2 and 2, and the half makes it one whole. So we have we have 3 and 2. 3 out of 2.
We're always looking for a relationship of 3 parts to 2 parts, but those parts can be different sizes,
Yeah,
and they don't have to be whole numbers.
right. So then that's where we combine the 2 halves and make a whole. No?
I'm not sure I'm following you. Can you say more about that?
Because we got 2.5
Mm-hmm.
Mona Lisas
Tall. Yep.
tall and 2.5 width. So I use the 2 that we have, and then the other half I make it into one whole.
Okay, so you're saying you want to take the extra half that goes this way
This way and the
and
extra
put it with the half that goes this way?
Yeah.
Okay.
I don't know.
Sometimes we can do half and half together. These are kind of these are different halves, if that makes sense. This is half a Mona Lisa's height. This is half a Mona Lisa's width. And they're measuring different things. But I like how I think like you're wanting a whole number, right? We're wanting a whole number because we want to see that 3 to 2,
Yeah,
right? Is there a way to think of the 7.5 as 3 parts? Like what you know how we took the 30 inches and we broke it into 3 parts? What happens if we take the 7.5 and break it into 3 parts? Can we do that? Even though it's not a whole number?
the 7.5.
Yeah, like the height here. What if we broke it into 3 parts?
When you say 7.5, like
So
we
that's,
divide,
what's that?
we divide.
Yeah, you could think of it as dividing because dividing is breaking into equal parts. So this one, D, is 7.5 inches tall. So I want to know, can we divide that into 3 equal parts?
2.
Like 2 inches?
Yeah, no.
So you'd have 2, 2, 2. That'd give you 6. So we're getting closer. It might not be a whole number, but that's okay if it's not a whole number.
We can get 3 out of the 7.
Tell me more. What do you mean?
You said if we break the 7.5, we can get 3 2s out of 7, but we still remain in the half.
Well, so let's say we had 2, 2, and 2. How much does that give you?
6.
That gives you 6.
Yeah.
Okay. So we didn't quite use up all the space.
Ah. So we use 2.5. 1. Another 2.5.
Let's use like
If we use
Say more. 2,
3, like 3.
15, like 2.15 or 250. 15, 2.15. Okay, so let's try that. 2.15. What happens if we do that 3 times? Do we get 7.5?
Oh, no.
We are a little closer though, because now we're more than 6, so we're getting closer. So she was suggesting 2 and 1500ths.
Can we go with 250?
250?
250, yes.
Like 2.5?
Yes, 2.5.
Okay. So what happens if we do that 3 times?
Gonna make 7.
7.5.
7.5. Well, that's what we wanted, right? We wanted 7.5 in 3 equal parts. But the parts turn out they're not whole numbers of inches. They're 2.5. So we could have 2.5 inches, 2.5 inches, 2.5 inches. That's 3. Now, what would happen if we did that down here? 2.5 inches this way,
And
2.5 inches this way. How
5.
much is that? 5. Which is the width. Okay.
Okay.
So it actually turns out that D is in proportion. When we looked at it, we thought it was, but it works out with the numbers too. Right? Whether we think of it as 3 groups of 2.5 and 2 groups of 2.5, it's still that 3 to 2, 3 parts to 2 parts, right? Or if we're using our part as the Mona Lisa, we could say it's 2.5 times as large and 2.5 times as wide, which is a little harder to see, but like it still works that way. But we weren't dealing with a whole number. So it turns out D is a good reproduction. It fits that ratio. All right, folks, so here's what we're going to do. First of all, I want you to, again, separate out just the ones that were the good reproductions, the ones that were in proportion. So that would be A, C. Oh, you guys are so organized. You already put them away. A, C, D, and F. These are the good ones. So separate those out. A, C, D, and F. Okay, these are the ones that were good. We checked their measurements. We know that they're in proportion. Yep. Okay. And we actually have a 5th one that is also in proportion, which is this piece of paper itself. Yep. A, C, D, F. And your paper is what we created on Tuesday. The paper that you have is 30 inches tall and 20 inches wide. So this is the size of the actual Mona Lisa, is this big white paper. And then the ones that you just separated out, A, C, D, and F, these are the good reproductions that are all in proportion. So here's what you're going to do. Start with the smallest one. And you're going to need a pen or a pencil or something to write with. You're going to put it in the corner, all the way in the corner of your big one. All right, and I want you to trace around it with a pen or a pencil. Okay. Like that. All right, so it's got to go all the way into the corner of the big one. We've got little reproduction, actual size. Okay. Once you've traced around, okay, yeah, that's fine. Yep, because Maria had to leave. All right, then take another one that's a good reproduction. After you've done the first one, just trace it one time right in the corner. Okay. Now you're going to take another one. You're going to do the same thing. You're going to put it in the same corner, all the way into the corner. And you're going to trace this one. Okay. So you're going to end up with rectangles that are like inside of other rectangles like that. So you're lining them all up all the way into that corner. Then do the same thing for the other ones that are good reproductions. Yep, line them up with the edge of the page, and again, you're getting rectangles inside of rectangles like that. And I think the biggest one is F.
Take your time.
Like that. Yep. Nice. So you should end up with 4 rectangles in the corner. Now I'm going to put this on a more solid surface because look what happens to that. So I can make it clearer with a marker. I'm going to get you guys some markers so you can make yours clearer too. All right, so trace around those rectangles, make them nice and clear. Pick one of those colors, actually make them all the same color if that's okay. So we want to really be able to see those rectangles like this. Yep. Down and like this. Boom. Okay. Yep, make them all the same color. We're going to use the second color for something else. Yeah, so if it's okay, make them all the same color. So I think, I'm just going to label I think this was A, C, D. I just labeled the letters of the ones that were, because the little one was A, C, D, F. Those were the 4 that we traced.
Yeah, that's good.
Nice. Okay. Then the last thing you're going to do, same color marker. Make a little star in the corner of each one. Like that. Okay, so what I did, I made a little star in the corner. Just like that. Yep. All right. So now that we have this,
That's A.
yeah, these were A,
No, A, C.
C, D, F. Those were our good reproductions. Okay. Yep. C, D, F. Okay. What do you notice about these rectangles and the stars that we made? Do you notice anything about them?
Yeah. What are we looking for?
Anything that you notice?
Well, what I've noticed, each square in here represent 1 inch. So we have 1, 2 for the first A. For C, we have 3. For D, we have 5. And for A, we have 6 inches
Okay.
in width. And for the length, we have 1, 2, 3 for A, and we have 1, 2, 3, 4 and a half.
And a half,
5 for C, and for D we have 1, 2, 3, 4, 5, 6, 7 and a half for D. And we have for F 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
9 for F.
Nice. So the size is, and it's nice, I gave you guys the ones with the grids. Actually, I
Yeah.
didn't give you the ones with the grids. the size is what gave us those numbers
The
that we were working
numbers.
with too, right? So the sizes on each way are actually representing those numbers
number.
physically, okay?
Yeah.
All right, we're gonna add 2 more stars.
Really interesting though.
2 more stars. So take your same color,
Yeah.
okay? The first star, sorry, I can't get this off. Ugh. The first one is gonna go down in the corner, as if we shrunk it down to nothing, right in this corner, little nothing. The other one, remember I said we have a 5th good reproduction, which is this whole page, is in proportion. So we're gonna put another star up here for the whole page, okay? That's the actual size painting reproduction. Ah, what are you doing?
Just line up the stars.
Excellent. So what do you notice about them?
It goes by the inches, how it breaks up.
It's a little harder for me to hold it up, but it looks like you guys discovered this at the table, right?
Yeah.
All of the stars that we drew,
Yeah.
they all fall in a line,
Yeah.
okay? If you have a pencil, I want you to trace that line with a pencil. You guys, okay, you have a pencil.
You don't want to make that hard.
Yeah. Right in the middle.
And that line actually connects all the way from one corner to the other. And all of those good reproductions fall in that line. Okay. The goal of that lesson was to introduce the idea of the straight line test, basically, but to introduce this idea that ratios can be represented on a graph. That's where this is going to go next, is actually graphing different ratios. And it eventually moves to this idea of slope, right, and establishing that understanding of how a slope is a ratio. That will eventually be a foundation for linear algebra. But the goal of today's lesson was just to kind of give them the beginning of that aha moment, that there's some connection between the fact that these were in proportion and these, similar rectangles, even though I didn't use that language, that there's a connection between that and having them all fall on a line. And I also wanted them to tie it back to, we've been working on the property of equal ratios and having the same factor. And so I wanted them to see that they could use now both tests to verify that something was proportional. All right, now that you have this, those are all the good reproductions. I want you to pull out one of the bad reproductions, one of the ones that was distorted. My bad reproduction.
This one.
So I think E was 1, G was 1.
B. Yeah, you got it.
So for example, G was the tall, skinny one.
Yeah.
Now, if we do the same thing with that, that corner does not line up.
No.
Okay, so that was
Maybe the same
G.
with the,
What's another one that was distorted?
oh, no. You actually do that. No.
We had, which one? E. Okay, E was the one that was a square.
E and B.
Yeah, E would like E would.
So if you put E and you look at the corner, it also doesn't line up. Oops, doesn't like me touching it. Okay. And I think the last one, there was one like this. Was that B? There's a little one that's stretched. Okay.
No.
Same thing. Doesn't line up. Okay. So what we're going to be looking at in this unit is that there is a relationship between things that are in proportion, proportional relationships, make a straight line. And this actually happens, although we're looking at it with pictures and shapes and reproductions, this actually happens with all kinds of proportional relationships and ratios. There's a connection between that and a straight line. Okay? Nice. Now, based on that line we just made, See if you can draw another rectangle that would be in proportion. Another size that would make a good reproduction. Does that make sense?
Another from another side, like
Another size. So like draw the rectangle
right here,
that you think would make a good reproduction.
the other half.
Right? So like you don't have one to trace, but like, you know, draw another rectangle on this
On this?
that you think would be a good reproduction.
For a bigger size, maybe.
Right? You can make it big, you can make it small, but you have to be able to explain why it would be a good reproduction.
2, 3, 4. We can do 4. I'm just thinking the market.
Forehead.
Yeah, if we go here and then, so we use 4 going up, and then 1, 2, 3, 4.
And 4, yeah.
That you think that will work?
I think so.
So we have how much going up again?
4? Yeah.
Okay.
Can we do 4 in length and 3 going across?
No, 4.
Well, let's see what it looks
4,
like.
4,
And then we can decide.
4 and 4.
Okay. Let's see what it looks like. Go ahead. I mean, you can use a pencil if you don't want to commit. How much is it in inches? Since you've got that on the grid anyway.
2 inches, 1, 2, 3, 4, 5, 6, 7, 8 inches.
Okay. And how many this way?
12
12.
12.
Yeah.
So you have 8
And 12.
and 12.
Yeah.
So 12 over 8. Here, I'm going to sneak out here for a second. 12 by 8. Let me add that to mine so we can look at it together. They were getting confused between whether the factor that they were repeating it by was the same, right? That means it's proportional. But the factor they were repeating it by wasn't necessarily a 3:2, which was the original ratio, right? So I think they were mixing that up. I think that in one of the later groups, I was able to sit down and kind of show them like 2 different ways they could see the factor of 4. Because that's really what was happening. We were shifting back and forth between 2 different ways you could see why this ratio was multiplied by 4, which is super valuable. And I expect that misunderstanding is going to come up again, and that we'll look at it, and because it's not so much of a misunderstanding, it's just that there's like 2 different ways to see it. So how do we know that your rectangle is in proportion to the others? Those were your measurements, right? You had 12 inches and 8 inches.
Yeah, but if we have 4 to 8, we still pretty much. We're gonna still get this because it's not gonna be the same. We have to keep it within the yeah. But this is how I was looking at it, right? Is how I vision it in my mind. We're stretching the Mona Lisa. So I use the Mona Lisa. I do this. 1, 2, 3, 4. So, and then coming down, it's 4 over 4.
So
So
how much taller and how much wider is it?
if we do that,
Like how much taller is your version than your little Mona Lisa?
How much taller the little and the
Like how many
long
times did you just do that?
This one you got a 4.
Okay, so it's 4 times taller and 4 times wider.
Yeah.
Okay. 4 times taller, 4 times
Wider.
wider.
looking at it. 3 and is like the 3 and the 7 and
So I think here's what might be confusing you. Tell me if I'm right. There's two different ways to see the number 4 in this. One way is what you were doing. It's 4 times wider and 4 times taller. That's a way of showing that it's in proportion. Because you multiplied the width and the height by the same thing.
Yeah.
Another way to see the number 4, right? We said that original ratio was 3 to 2. Okay. Where do you see the number 4 here? 3 groups of 4
Yeah. And
to 2 groups of 4. Those are
Yeah.
2 different ways
Different
of
ways.
seeing that factor of 4, right? So it's interesting because they're sort of parallel ways that the 4 can be seen. We can either see it as we took the Mona Lisa times 4 in both directions,
Yeah.
or the original also had 2 and 3, but these were only 1 inch.
1 inch.
Now each of those parts is 4 times the size, so they got bigger.
Yes.
Does that make sense?
Yeah.
Okay.
A whole lot of sense.
And if you look up there, does that look familiar?
Yeah.
Property of equal ratios, right? The numbers show us the property of equal ratios. So what we have here, this was our old way of looking at how we know 2 ratios are in proportion if we can find a factor that's the same on the top and the bottom. But now we have a new test. Our new test is also, does it fall on the line? Right? So you just proved that these are in proportion in 2 different ways. Because you drew them, we can see that it falls on the line, and that's called the straight line test. Right? They're proportional because they fall on that same line. And we can also show it numerically with the property of equal fractions. Okay. I do have students who struggle with things that traditionally they associated with being good at math. You know, they'll say, well, I was never able to memorize my times tables. And like, to see there's a lot of ways to be good at mathematical reasoning, even if they have specific gaps or specific struggles, or if they can't remember the steps. There's still ways they can be really strong in mathematical reasoning. And so seeing people kind of shift their perception of like what math can be, who they are related to it, what it feels like to them, like that's what's really rewarding to me. And I think when people experience having success at something that's challenging, it shifts how they think about it. That's what I like. I like seeing people who were, really scared of math and, had so many negative experiences. Now they're like, this is fun. I like this. It's intriguing. They find themselves, explaining things to other people, or suddenly discovering that they're really good at this one math game. It's really rewarding. So that's why I do it. And I'm fortunate that I'm able to, that I can have a full-time job in adult education and do this. I feel really lucky.